Welcome to my Stata teaching video about cross-tabulation and measures of association, part 2. In the previous video clip, we demonstrate how to use Stata to draw a cross-tabulation of two discrete variables. We talked about how to understand the frequencies in the cell and the marginal frequencies, row margins, as well as column margins. We also talked about three definitions about percentages, row percentage, column percentage, and cell or say overall percent. By the end of the previous video, we talked about a concept of degree of freedom, which can be calculated by the total number of rows minus 1 times total numbers of columns minus 1. In this part, we are going to talk about statistical independence and a chi-square test of statistical independence, as well as three commonly used measures of association between two discrete variables. In the previous video, we can list a cross-tabulation using the observed frequencies, or if you prefer, you can calculate row or column or cell percentages. And by observing those frequencies or percentages, maybe you can detect some patterns between these two variables. For example, are males more likely to have higher level of general trust than females? Or is any given racial group more likely to have a higher level of general trust? All of this fall into the field called Descriptive Statistics, which means you are observing things simply from your empirical data. It's very difficult to do census, so most of the time we depend only on random sample surveys to study the entire population. And our final goal is to make a statistical inference about this unknown population. Maybe we observed something from our empirical data, but that pattern is from our current sample. Maybe our current sample was contaminated by random sampling error, so this observed pattern may not exist for the entire population. In order to investigate or say do some statistical inference about the entire population, we need to do some hypothesis testings. Do we still have this kind of a relationship or pattern for the entire population? That's a key question for this part. We can use something called chi-square test to demonstrate is it very likely for the entire population that we still have two discrete variables related to each other in a certain pattern. The null hypothesis for this chi-square test is that two discrete variables are statistically independent from each other for the entire population. The research or say alternative hypothesis is two discrete variables are not statistically independent from each other for the entire population. Most of the time, we want to reject the null hypothesis and in favor of the alternative hypothesis so that we can continue our investigation to talk about measures of association between two variables. So, the first step is to test statistical independence between two variables for the entire population. To get this job done, we only need to include the CHI or say chi option to the cross-tabulation command. For example, if we want to test a sex and general trust level statistically independent for the entire US adult population, we can list a cross-tabulation of respondents' biological sex and the dummy variable of trust we generated last time, followed by an option of CHI. So how about we highlight row 59 and click on the Do button. In the output, we have the same cross-tabulation, totally 1683 cases. And below this cross-tabulation, we have something called Pearson chi2, which means chi-square, followed by 1 in the pair of parentheses equals to 8.5089. So this is the chi-square value Stata calculated for us for this cross-tabulation of 1 degree of freedom. And the probability for us to see this chi-square value for a degree of 1 cross-tabulation is only 0.004. So this value is called p-value. It is the probability of making type 1 error. Or say, this is the probability for you to wrongly reject a true null hypothesis. We want this probability of making type 1 error to be as small as possible. Usually, we set up the threshold of 5% to be the standard. If this p-value is less than 0.05 or say 5%, it's relatively safe for you to reject the null hypothesis and in favor of your alternative hypothesis. For this particular case, the p-value of making type 1 error is only 0.4%, which is way much smaller than the 5% threshold. So we can go ahead and reject our null hypothesis. That means for the entire US adult population, it's highly likely that respondents' biological sex and general trust level are not statistically independent. This conclusion could be wrong, but the probability of making type 1 error is only 0.004. This is how to read output of Stata for a chi-square test. How about we practice this skill for another example? Are risk and general trust level statistically independent for the entire US adult population? If you want to answer this question, you need to list the cross-tabulation between risk and this dummy variable of trust level, followed by an option of chi. And then let's see the result by highlighting row 64 and 1. You will see this time the Pearson chi-square value for a cross-tabulation with 2 degrees of freedom is 46.1457. The probability for you to see such a large Pearson chi-square value is almost 0. I should emphasize one more time, 0.000 is not equal to 0. It's almost 0. This value is so small, and by default, Stata only demonstrates the first 3 decimal places. So, using the same logic, we can go ahead and reject the null hypothesis. That is to say that for the entire US adult population, it's highly likely that race and general trust level are not statistically independent from each other. This conclusion could be wrong, but the probability of making type 1 error is way much smaller than the threshold of 5%. This is how to read and interpret chi-square test result from Stata. Now we know that respondents' biological sex and general trust level, these 2 variables are not statistically independent from each other for the entire population. That means these 2 variables must relate to each other in a certain way for the entire population. So how to measure the level of association between 2 discrete variables? There are several choices. Number 1 is called Cramer's V. This measurement is okay for any kind of discrete variables. These 2 variables could be non-orderable discrete at the same time, orderable discrete at the same time, or one is non-orderable while another one is orderable discrete. It doesn't matter. It applies to all the situation. In order to calculate Cramer's V for two discrete variables, what you need to do is to replace the CHI option by an option called V. Be careful that your Stata is case sensitive, so you have to specify this option in capital letter V. So let's see the result. Highlight row 68 and click on the Do button. We have the same cross tabulation one more time. While below this cross tabulation, we have Cramer's V equals to 0.0711. We can try it for another example. We have already known that reach and the trust level are not statistically independent for the entire population. So how closely are these two variables related to each other? We calculate Cramer's V for these two variables. List the frequency table between two variables and followed by an option of capital letter V. So highlight row 70 and click on the Do button. You will see that these two variables have a Cramer's V value of 0.1656. What do you mean by 0.1656? There's no clear physical meaning of this value. So different subjects, different fields, they will define different thresholds to differentiate weak from strong association. In sociology, sometimes we use 0.4 as a cutting point between weak and strong association. If we use this standard, 0.1656 is smaller than 0.4. So that means these two variables, they are not statistically independent from each other. They are related to each other, but this relationship tends to be a very weak relationship. If you have two orderable discrete variables, then you can have more choices of measures of association. For example, Goodman and Kruskal's gamma, as well as Kendall's tau b. Let's talk about this two measures for orderable variables one after another. We have a research question like this. Attitudes towards immigrants and confidence in federal government statistically independent from each other for the entire U.S. adult population. In order to answer this question, we need to list a frequency table for two discrete variables, IMM, AMECO, as well as CONFED. These two discrete variables are all orderable discrete variables. And then we provide a chi-CHI option to this cross-tabulation command. And let's test the statistical independence between these two variables first. So go ahead and highlight row 76 and run. You see that there are 5 categories which can be meaningfully sorted in this manner from strongly agree to strongly disagree for a variable IMM-AMECO, which means immigrants are good for America. Another variable, confidence in the executive branch of the federal government, contains 3 levels from a great deal to hardly any. So this one is also an orderable discrete variable. Since we have already issued the command num label, add, so by default, the coding scheme as well as value labels will be displayed together. This could be a nice feature if you want to see how variables are coded, but for this particular case of cross-tabulation, some letters of value labels got trimmed off. So if you want to see a complete value label, a good practice is to remove the coding scheme from value labels first, and then list the cross-tabulation so that you can see the entire value label. To do so, you change the add option of num label to remove, and then you list the same cross-tabulation one more time. So how about we highlight row 79 and 80 together and then click on the Do button so that you can have a better presentation about your result. And this time, we have only value labels left without coding schemas. So it's relatively easier for you to see value labels, particularly for the column variable, because the space here has been predetermined by Stata. And for this particular case, the chi-square of a cross-tabulation of degree of freedom equals to 8 is 26.7080. And the probability for you to see this chi-square value is somewhere around 0.1%. This is also the probability for you to make type 1 error. And this value is less than the commonly used standard of 5%. So we can go ahead and reject the null hypothesis. That means that for the entire US adult population, attitudes towards immigrants and confidence in the federal government are highly likely to be not statistically independent. This conclusion could be wrong, but the probability of making type 1 error is less than 5%. Now we know that these two variables tend to be related to each other in certain way for the entire population. And then we can go ahead to calculate how closely are they related. On row 83, we provide a gamma option to this cross-tabulation command, which will give you the calculation of Goodman and Kruskal's gamma measurement of association for two orderable discrete variables. So highlight row 83 and click on the Do button. You will see this same cross-tabulation one more time, and below it you have the gamma value, which is 0.1830. This value is a positive value, which means two orderable discrete variables tend to relate to each other in a positive way. Here the term positive means majority of the frequencies inside this cross-tabulation tend to fall into diagonal cells. That means from upper left corner to the lower right corner. That's how to define positive if you have two orderable discrete variables. Interestingly, we have another statistic called ASE ran next to gamma. This one is actually the p-value for a hypothesis testing of gamma equals to 0 for the entire population. If we use 5% as usual as the threshold of significance, then this ASE is less than 5%, which means that for the entire population, it's highly likely that the gamma measurement of association is different from 0. In addition to gamma, we have another measurement called tau b. It carries similar meaning. And how about we go ahead and highlight row 90 and click on the Run. And then in the output window, you will have candles tau b calculated for you. This value is 0.1186. It's positive, which means most of the frequencies inside the cross-tabulation tend to fall into diagonal cells, starting from upper left corner to lower right corner. And we have a ASE, or say p-value, for this candles tau measurement, which is less than 5%, so you can be relatively sure that for the entire population, the measurement of tau b is different from 0. This conclusion could be wrong, but the probability of making type 1 error is less than 5%. Now you see that both gamma and candles tau b, they are all positive. If we look at the magnitude, is some kind of problematic, because there's no absolute or widely shared standard about the meaning of the magnitude. So in social science, sometimes we tend to use 0.4 as the standard. So if the magnitude is larger than 0.4, then this association tends to be strong. If the magnitude is less than 0.4, then this kind of association tends to be weak. but there's no consensus across disciplines. That's everything that I want to cover for cross-tabulation and measures of association in Stata. Before you leave, close your log file by run row 93 and then clear the memory so that you will not destroy your original data accidentally. Thanks for watching. See you next time.